Hello, this clip is to show you how to calculate one-way ANOVA step by step using Excel. This example is directly from the textbook, so you should read the book to be familiar with the formula, the steps, and the rationale behind it. So this is the case. Okay, right here. Now we have four cultures here on how much they treat others fairly. Research suggests that it seems people of lower socioeconomic status tend to be more generous. So here we want to examine the hypothesis that there is a significant difference among people of these four cultures on treating others fairly. So here are the data, those numbers. See here. The idea of ANOVA is comparing the ratio of between group variance and within group variance. So between group is the difference across those groups, right? And within group is the difference among those scores within the group, right? So the idea is that if the between group variance is very way bigger than the within group variance, then we have a significant finding. The first step is, of course, calculating the means of each group. And but at this point, you should know how to do it. So highlight the whole thing, right? Okay, so that's the mean for each group. But now we also have to calculate something called the grained mean, which is the mean of each data point. Yeah, every data point, right? And which is easy to calculate. You just do the same thing, average, and then you highlight the whole data set. Right? So that's the grained mean. Okay, the next step is to calculate the between group and within group. Now, personally, I prefer to calculate the between group first. So, first we use each group mean to minus the grain mean. Okay. So, here, this minus this, we can just select those means, those cells, no problem. Okay. Now, the farming, this one minus this one, so on and so forth. So this is natural resources, right? Okay. And then finally, industrial. Okay, so see, we have the deviations of each group from the grain mean, right? Again, you see those are negative values, positive values, and as usual, we don't want that. So we have to get all the positive values, and as usual, um, uh, the next step is to square them, right? So this into little hat and square. So, select this, this. Okay, so those values are positive. The next step is we need to multiply each value with the sample size of each group, because there are these are the average value. Those are just average, right? But what we want is the total sum of square. So we can calculate, we can divide it by degrees of freedom to calculate the estimated variance. But anyway, just remember we need to, this step is to times the sample size. Okay, so for foraging group, this is foraging culture is sample size is 4, so times 4. Now for farming, sample size is 3, so you times 3, so on and so forth, times 3 and times 3 because sample size is 3. Okay. Then the final step for the between group is to add them up. Okay. Sum and then you highlight all this value. Now you see I highlight this value red because it will be easy. This is an important value, so after all the calculation, I want to be able to refer back to this number easier. Okay, so this is between group variance. Actually some square. Now we want to calculate within group, and it's similar to what we have done before in t-test, z-test. Okay, so first we get the deviations by using each data point to minus each group mean. Now within group, select this minus. Now for the mean right here, 33.25. Type it out. 33.25. It will be easier. Okay. Now there are 4 data points, so you highlight 4. Okay, no more, no less. And then, of course, the next step is to square them because some negative, some positive. We don't want them. Okay, so we select this square, right? We can try that easier. Okay, then we get a sum of these values. Go to Home tab and then Auto Sum. Farming is the same, so select this. This 35. So select 3 because that sample size is 3. Now square those values. Right? And then get the total. Natural resources culture is this minus. Okay, now the mean is a 47.33333 and so on and so forth. We just select 2 digits, so 47.33. Okay. Then so finally industrial. This take away 44. And square it. And then get a total. Alright, so we have those 4 values. We need to add them up. Okay, then again sum parentheses. Now select this value and comma, select comma, select comma, select. Okay, so as usual I highlighted red because it's an important number. So now we have these 2 most important values. The next step is I refer to this table. This will help us to calculate this F ratio. So see, this is between groups and within groups, right? The sum square, degrees of freedom, mean square, which is actually variance. And so this is filling in the blank. Okay, so between group equal, what I would do is just select this value and then enter. Within group is the same, so select equal and then select this value. Now we need to calculate the degrees of freedoms for between groups. And what is that? How many groups are there? There are 4 groups. So 4 minus 1 is 3. So the degrees of freedom for between groups is 3. Easy. Now about within group. Now we need to calculate the degrees of freedom for each group. So for origin there are 4. The simple size is 4. So 4 minus 1 is 3. So this group's the degrees of freedom is 3. For farming, it's 3 minus 1, so it's 2, and so on and so forth. So, in other words, the within group degrees of freedom is 3 plus 2 plus 2 plus 2, which equals 9. Okay? Mean square actually is a variance, estimated variance, is this value divided by this value. So, equal this divided by this. And then, within group, this divided by this. Alright, so F is the ratio between these 2 values. So equal this divided by this. Alright, so this is the answer, F ratio, 8.27266. Um, but now we need to decide if this value is in the critical region. In other words, if the result is significant. So we need to go back, refer to critical value, and let's check the book. Okay, appendix is in B4, and at the bottom this is a F distribution. Um, to find out the critical value, we need to know the degrees of freedom. So this is a between group degrees of freedom right here, and this is within group, this column. And there, our within group degrees of freedom is 9, so obviously we need to move to the next page. So now look at this. Degrees of freedom is for between groups 3, and then within groups 9. So it's this block. Look at the alpha level, 0.01, 0.05, or 0.10. We always go for the 0.05. So it's this value, 3.86. This, write it down, 3.86. Okay. Alright, now, excuse me. We need to compare this value we calculated with the critical value. And at this point, by now, you should know this bigger than this means it's significant, right? In other words, we need to reject the null hypothesis, okay? Which means there's a significant difference among these four cultures on treating others fairly. This is how you interpret the data. Okay, this is the decision. This is interpretation. So now it is significant that also we know the p-value is the same, 0.05. So that's how you calculate that. Now, the next question usually is, okay, so we know some difference across this groups, but which pair? I mean, where is the significant difference, right? So, for example, like is this value for origin much less than uh, natural resources or industrial, or what about farming, right? Now, the answer depends on whether we have a theory to support our prediction. If we have theory, for example, theory suggests that foraging probably is treating people more fairly than other society, or vice versa, or whatever, right? In other words, if we have a theory to support our prediction, then we use something called planned contrast. But if not, if there's no any theory to predict whatsoever, then we use something called post hoc. Okay. Now the difference between these two is like one tail versus two tail. One tail, this is more lenient. Okay. In other words, easier to find the significant difference. And post hoc is more strict. That's all you need to know. Okay. Now, of course, you always can go to data tab and click on data analysis to check if your calculation is correct. So you see there are three ANOVA calculation, and which one should we choose? What we are calculating is one-way ANOVA. Now one-way means one factor or one independent variable. So this is what we choose, a single factor. Okay, so look at here. Actually, for this input range, you need to highlight the whole dataset. Okay, and usually I prefer to select output range. Okay, output range, you just click whatever you want. It display the analysis result. Okay, so that's it. Okay, so now you look at this. Those means we calculated compare with this is identical. So we are correct. And also look at the table, right? These values the same, identical with this value. See, what I forgot to calculate is the total, but it's not really important. Let's just do it. Go to home and then auto sum. Auto sum. That's it. All right. So you're correct. And look at this calculation. The p-value is exact p-value is at 0.005919, which is much less than 0.05. This suggests to us it's a significant. That means we need to reject the null hypothesis.